I want to go back and talk about the sine and cosine ratios that we had up here on this that I had you work through on the slides. So you should have noticed a little bit about these triangles. Again, obviously they're similar, right? Because you got the two angles, the two right angles, and the common angle at D. So if I slide this n, if I slide the n, let me try sliding the n. It's not sliding the n. This is now it worked before, of course, when you guys before I tried this out. Let me do a refresh on it here and see if we can get it to go. Okay, so as I slide that in, then those triangles, all right, are similar because the D angle staying the same, and the right angle at C and F are staying the same. So then these are my new ratios, which we said are, well, I guess it doesn't quite say what they are, but you can see that they're staying the same. Okay, so let's go down to here, and here are some the ratios spelled out for us. It says the rataha is adjacent over hypotenuse, so that's from angle D. Everything's from angle D. So remember the adjacent side would be the 5.33 because it's next to it, and the hypotenuse, of course, is the 6.16. Right, then the other one is rataho, okay, so that would be opposite over hypotenuse. So in that case, that would be 3.08, and the hypotenuse is still 6.16. And it just says as you change this, all right, the cosine and the sine correspond to the rataha and the rataho, right? So those are our trig ratios, all right, that we have, our brand new ones, and our last ones. So sine of the angle, just like with tangent, all right, is equal to the opposite side, all right, over the hypotenuse. Okay, there you go. And the cosine, by the way, they abbreviated that way, of the angle is equal to the adjacent side over the hypotenuse. So now we have these trig ratios, newer ones anyway. So we have three, sine, cosine, and tangent. And they work kind of in the same way. Although the sine, the cosine are maybe a little bit trickier, only because I think it's, you get those other ratios, and tangent was pretty simple, just opposite over adjacent, where now you have opposite over hypotenuse and adjacent over hypotenuse, and which one is which, and that kind of thing. So let's just do some examples here real quick. And the tangent, there was just 3 examples, but for this one, there's many different situations we can have. So I can't just say, here's our 3 different situations. So let's do this. Okay, here's our right angle. I'm going to put an angle here, and we'll call this 160. All right, and we'll put a side right there. So now we want to try to find both A and C. All right, so what we'll do is oops, there we go, is we'll go ahead and find, let's go ahead and find C. I have the side that's opposite, and I want to find the hypotenuse. Okay, so I'm going to use opposite. Okay, opposite is the side I know. Hypotenuse is what I'm trying to find. That's going to be sine. So I'm going to go sine of 60 is equal to the opposite side, which is 8, over the hypotenuse, which is C. And I'm going to do the exact same thing that I did before. I'm going to use my calculator. I'm going to use decimals. Let me get rid of all this stuff. All right, and let's go figure out I'll make sure I'm in degrees first. Let's do the sine of 60. It says it's 0.866. So I go 0.866 over 1 equals 8 over C. And just like on the other ones, we're going to go all kinds of cross multiplying to do it. So we get 0.866C equals 8, and then we'll divide that. So once you know which one you're doing, it's pretty much the same thing as the tangent one. (9.23). Alright, now if you know C, you can easily find A by just using the Pythagorean theorem. Alright, so we're going to go A squared plus B squared equals C squared. A squared plus B squared equals C squared. Alright, we know B is 8, and we know C is 9.2. Because C, remember, is always opposite to 90, and then we just have to find A. And you guys are pretty good at this part. So I got 64 there. Got to go find 9.2 squared. 84.64. And let's see, we'll do a little work here. So A squared is equal to 20.6. And then I just got to square root that. 4.5. Okay. And that's pretty much how that stuff works. So let's do another one like that. Draw another triangle. Okay, I'm going to put my angle up here this time. I'm going to call it 70. Here's my 90. I want to go make this 10. Alright, I want to find C. Alright, this time I know the side that's adjacent because it's right next to the angle. Remember, you always want to locate the angle first. Okay, locate that angle first and then figure out which side you know and which side you're trying to figure out. So this is the adjacent side. This, of course, is the hypotenuse. So that's going to be a cosine example. So cosine 70 is equal to the adjacent side, which is 10, over the hypotenuse, which is C. Now I'm going to go get the cosine of 70. And it's up here just like sine is. They're all right here. I'm in degrees. I don't have to check anything. There it is. 0.342. Try to write it out so you have 3 decimal spots there. Cross multiply. Here we go. And then we'll do some division. 29 point. There we go. Alright, that's how you find that one. Okay, we're going to continue on here. Like I said, there's quite a few of these types of examples. They might tilt this triangle so it looks like this. That shouldn't throw you. You got to find that right angle. Alright, so this time here we got a hypotenuse of 10 because it's opposite to 90. The side opposite is the one that I want to know. There's my angle because I'm always locating that first. Opposite over hypotenuse. I know that's cos or sine. So I go sine of 40 equals opposite A over hypotenuse 10. Let's go find the sine of 40. 0.64. I didn't see the other number. I think it was a 2. Cross multiply. This one's a little easier to multiply because I just take 10 times that. Okay, and there's my A value. Alright. Okay, just like tangent though, we're going to have an example here. Oops. We're going to have an example where we need to find an angle. So this time we'll put this here. Alright. I want to put 8 on this side and 14 on this side. And this time I want to find this angle. We're going to call it A. Okay, so this time I can locate the angle, but it's obviously not there. But it's the one I want to find. So I'll go opposite hypotenuse. Opposite hypotenuse, that's got to be a sine. So I'm going to go sine A equals opposite 8 over hypotenuse 14. I don't know what the angle is, so I'm going to use that little inverse thing that I did with tangent to find the angle. So I'm going to come down here. That guy is going to be right there. So I'm going to go 8 divided by 14. Pretty sure that's what it was. And I get 34.8. Yep. So angle A is 34.8 degrees. Alright. There you go. And that's your sine and cosine. If you need a little, this has kind of been used a lot. Okay. So the old SOHCAHTOA thing, but really, it used to be like sine. So this is sine, okay, and this is opposite, and this is hypotenuse, and this is cosine, and this is adjacent, and this is hypotenuse, and this is tangent, and this is opposite, and this is adjacent. That's what those stand for, the SOHCAHTOA thing. So you can use that, sine, so sine, opposite, hypotenuse, cosine, adjacent, hypotenuse, tangent, opposite, adjacent. Okay, but, the thing is that's not really what that stands for. Okay, just so you know, it stands for some old hippie caught another hippie tripping on acid. So just in case somebody tells you that that's what it always was, nah, it was always the other thing. So take that with you, and let's see. I'm going to give you some problems with this, but probably not a lot, and then we'll go from there. Don't forget, put questions in the document. Bye-bye.